This is, whoa, my first attempt at teaching on this iPad and videotaping it, so bear with me. 12.1 is all about exponents. And I will follow along with pretty much the examples that are in the book. I'll just walk through them, talking what I'm thinking in my head and why things are happening the way they are. So if you want to look through the textbook and then you want to take notes while I take notes, whatever works for you for your learning style. And you don't have to use these if you don't want to either. They first talk about what an exponent is. And if I take 5 cubed, this 5 is called a base number. And this little 3 is called my exponent. So you do need to know that vocabulary. So if I have 5 cubed, that is the same thing as having 5 times 5 times 5. So this exponent up here tells you how many bases that you're going to multiply together. So 5 times 5 is 25, and 25 times another 5 is 125. So 5 cubed, when simplified, equals 125. The next part talks about evaluating. And there's a few problems that they go through, and I'll just walk through them. The first one is 1 plus 2 to the 4th power over 4. You have to go back and think to earlier math classes that you had about the order of operations. I'm going to run out of room here. I'm just going to abbreviate. If you went to Wahai, most of your teachers probably taught it like this, where they gave you a pyramid and they said you work your way down. At the top of the pyramid was parentheses and brackets. And then the next part was exponents. And there's radicals. We aren't going to deal with those today, though. And then multiplication and division, and you had to make sure you go left to right. And add and subtract, and then you got to make sure you go left to right on that. Some teachers taught it as PEMDAS, or please excuse my dear Aunt Sally. So we're going to take a look at this. This problem has multiple operations. It has addition in it, and it has an exponent in it, and it also has a fraction, which indicates that there's some division going on there. So we're going to look through this order of operations, and we're going to say, okay, well, I don't have any parentheses, so I don't have to worry about that. But the next level that I do have are exponents. So you're going to do your exponents first. So this part, 2 to the 4th, remember that means 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I'm going to rewrite this as 1 plus 16 over 4. If you try to rewrite your problems each time you simplify in one little thing, then you tend not to make so many errors. Now I can look at this part of the problem, and I can say, well, now I only have 2 operations. I have addition, and I have division. So which comes first when you come down this pyramid? Division. So I'm going to divide 16 divided by 4, which is 4. And the last part, I'm going to add 1 to it, so I get 5. So you just have to think about that order of operations. The next example that they had in the textbook looked like this. So if I wrote this out the expanded way, I would have 3 times 1/3 times another 1/3, because there's a 2, an exponent of 2 up there. So 1/3 times 1/3 makes 1/9. So I have 3 times 1/9. And then you can either use your calculator, or you should know how to multiply 1/3 times 1, or 3 times 1/9. 3 divided by 3 is 1. 9 divided by 3 is 3. So that's 1/3. So this equals 1/3. And the next example, I'm actually going to do 2 at the same time. They have example C, which is -2 to the 4th power, and then they have example D, which is -2 in parentheses to the 4th power. There's a big difference between these two, and this can get confusing. If you take a look here, if I asked you what is being taken to the fourth power on example C, the 2 is being taken to the fourth power, not the negative. But on example number D, negative 2 is taken to the fourth power. So if I wrote it out, when I write all the bases and get rid of the exponent, that's called expanded form. So if I wrote C out in the expanded form, I'd have the negative of 2 times 2 times 2 times 2. So that would be the negative, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I'd have negative 16. Notice that the negative didn't get multiplied 4 times. Just the 2's did. But over in example D, if I wrote it out, I actually have negative 2 times negative 2 times negative 2 times negative 2. Whoops, that's times. So negative 2 times negative 2 is positive 4. And positive 4 times 4 is 16. So D ends up being positive 16, but C ends up being negative 16. You might want to put a little star by this in your notes because it does become an issue for some students later on. It's a little bit confusing, and to go back and look at an example might clear it up. The next part is zero exponents. Something strange kind of happens when you take something to a zero exponent. So let me kind of show you, I want to prove it to you first in patterns. If I have 2 cubed, that's 2 times 2 is 4, 4 times 2 is 8. And if I have 2 squared and I drop my exponent down 1 each time, 2 squared is 4. And 2 to the first power is 2. If I take a look at the pattern that's going on here in the answers, in the simplified answers, from 8 to 4, I divided 8 by 2 to get 4. And from 4 to 2, I divided 4 by 2 to get 2. So if I keep following that same pattern, that means my next answer should be a 1. That means 2 to the 0 power should equal 1. So let me show you, and it does. So let me show you if I use a different base than 2. Let's use base 3. So 3 cubed is 27. 3 squared is 9, and 3 to the first power is 3. So if I take a look at this pattern over here again, 27 divided by 3, because it's base 3 this time, is 9. 9 divided by 3 is 3, and 3 divided by 3 should be 1. So 3 to the 0 power is 1. Anything to the 0 power is 1. Like if I take negative 4 to the 0 power, that's 1. If I take a plus b to the 0 power, that's 1. So anything taken to the 0 power is 1, which is just kind of strange just because it's different problems but yet the same answer. They have an example like this in there that I better cover. When you have these parentheses that go from the numerator to the denominator, it's actually telling you that 4 is being taken to the 0 power and 9 is being taken to the 0 power. Well, you already know that anything to the 0 power is 1. So 3 times 1 is 3. And then the last example in that section, they have x squared y to the 5th over 3z, and everything is taken to the 0 power. Don't let it confuse you with all the variables and exponents and numbers. This whole thing is being taken to the 0 power. So the answer is 1. The next section is called the product rule. There's 2 rules you're going to go over today. It's the product rule and the power to a power rule. Let me show you with numbers. They have a little thing up there that shows you with variables. So let me show you with numbers first. It usually makes more sense first. If I have 2 cubed times 2 squared, if I asked you to write that out the extended way, 2 cubed means 2 times 2 times 2. And 2 squared means 2 times 2. And there's a multiplication in between there. So that means everything is multiplied. And so I have 3 2's and 2 2's, so I really have 2 to the 5th power. So if you were asked to state that in an exponent, this would be your answer. If you were asked to simplify it all the way, then 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so that would equal 32. So it just kind of depends on what they're asking, but I'm focusing on this one for right now. Can you see a shortcut that can happen here with exponents? The shortcut to a product rule, and remember it only works on this part, this product rule, is to add your exponents. But it only works if your bases are the same. Ooh, getting sloppy. So let's go through another one. If I have x to the 4th times x to the 5th, that's going to be x to the 9th because 4 plus 5 is 9. If I'm not sure, I can always write it out. You're not going to want to write it out if there's, x to the 30th. That's ridiculous. But let's say you get confused on a test and you don't have any notes, or you get confused on your second homework assignment when you shouldn't be using notes. Then you can write it out and go, oh yeah, that's right, 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So yeah, the shortcut would be to add those. So in your textbook it shows you like a little box. It means that's important. And it shows you the rule using variables, so they don't use any numbers, so they can show you what happens just in general. So if you have a to the m times a to the n, then you have a to the m plus n. Here's another one. What if there's whole numbers in there along with your variables? What's being taken to the 2nd power is x. What's being taken to the 6th power is x. So the 2 and 5 are not being taken to any power at all. You can think of them as a power of 1, but I can rearrange these. All this is multiplication here, so I can rearrange this and put the like terms together. The 2 and the 5 can sit together. The x squared and the x6 to the 6th power can sit together. And now I can see that I can actually simplify 2 times 5 to 10. And I can actually simplify x squared times x to the 6th, 2x to the 8th. I added the exponents because of that product rule, or that product rule, excuse me. If I wasn't sure, I could write it out. X squared looks like that. X to the 6th looks like this. So altogether I have 8 of them. I don't think I have room for the next example. Okay. So the next example goes back to some distributive property. If you don't remember what distributive property is, even after I go through this example, I would definitely look it up on, Con Math or YouTube to remind yourself what that means. These parentheses mean I must do that first because of the order of operations. But the problem here is that I have 2x and I have 3x squared. So these are not like terms. And you learned in your earlier math classes that you can't add unlike terms. They both have x's, but x and x squared are not alike because they don't have the same exponents. So I can't add them. But what I can do is I can take x cubed and multiply them times what's in these parentheses separately. This is called distributive property. So I can go x cubed times 2x, and then I can go x cubed times 3x squared, and there should be a plus in between there, excuse me. And then I can simplify it. I can see that these two can be multiplied together. I have 3 x's there, and this is really 1x. There's a little 1 in the corner. So this is, if I simplified it, 2x to the 4th. Now again, the way I got the 4 is that I have 3 x's here, And because this didn't have an exponent, it's understood that there's 1, because there's 1x. Okay, so now I can take these two and put them together because it's multiplication. So I have 3x to the 5th, because I have 3 x's here, and I have 2 x's here. If I wrote it out, remember, if you get confused, write it out. And then I can't go any farther because I can't add unlike terms. So at that point, there's your answer. Here's another example. X times x cubed. So here's another example of where that little understood 1 comes from. There's really a 1 right here, because there is nothing there. If it was a 0, then x to the 0 power would be 1, or there wouldn't be any x's in there. So I have x, then I have 3 of them over here. So this is x to the 4th. Or I could use that shortcut of adding these two, right? And the final example in that section was a plus b times a plus b to the 4th. So remember, there's really a little 1 right here. So don't let it look confusing to you because you've got this a plus b. You've got 1 of these, and then you've got 4 of these over here. So if I wrote it out the long way, it would look like this: a plus b, there's the 1, and then a plus b, a plus b, a plus b, and a plus b. Getting a little messy. So there's 4 of them. So altogether, I have 5 sets of them. The next section is called power to power. And again, I'll show you with numbers first. If I have 3 squared and I take it to the 4th power, this is different because I have a power and then I'm taking it to another power. So I'm going to write it out the long way and you look for the shortcut. So inside here, that means I have 2 3's. And then this part of it means that I have 4 sets of those. So I have 2 3's, and I have 4 sets of them. So if I counted them, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of them. So I have 8, or 3 to the 8th power. The shortcut, then, would be that you can multiply exponents. Do you now see why I don't say don't memorize the shortcuts? Because if you get them confused, one is add and one is multiply your exponents. I mean, memorize them, but make sure that you can write them out to prove to yourself that that was the right shortcut that you were using. So let's take a look at this. Oh, and then in the textbook it has that little box there again showing you that if you take any number, take it to the nth power and then to the mth, that the shortcut would be to multiply the 2 exponents. So here's another example I had in the book. A cubed squared. So if and again, you don't have to keep writing it out, but if I wrote it out, this is what it looked like. I have 3 A's, and then I have 2 sets of them. So how many A's do I have altogether? I have 6 of them. I always remember, I would get these confused all the time. When do I add? When do I multiply? I kind of, in my head, think of that as a times sign when I see it. I don't know if that helps you or not. So here's another example that was in the book. 3z squared. This one's important to notice that there's a 3 inside the parenthesis and a z inside the parenthesis. So really what that is saying is it's saying 3 squared z squared. That looks like a z. Or you can think of it like this. 3z and then another 3z because there's 2 sets of them. So 3 squared is 9 and z squared is just z squared. Here's another example. Negative 2x squared times 3. So you have 3 sets of those. So you have negative 2xx, negative 2, 2xx, negative 2xx. So you could write them out the long way. Or you can think of the shortcut. Negative 2 cubed x squared cubed. And then think about what I said about the shortcut with those. So negative 2 cubed, negative 2 really has an exponent of 1 up there. So that's just negative 2 cubed. So negative 2 times negative 2 times negative 2. So negative 2 times negative 2 makes 4. Positive 4 times negative 2 makes negative 8. And then x to the 6th. Here's another example. So that means you have 4. You have x squared to the 5th and y cubed to the 5th. Remember, they're both taken to the 5th because they're both inside those parentheses. So I'm going to bring my 4 down. I'm going to use my shortcut here and here, but remember, if you couldn't remember the shortcut, x squared to the 5th means 5 sets of those. So xx, 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 xx. So x to the 10th and y to the 15th. And that would be my final answer. And to the next example. This one's kind of a tricky one. Goes back to those examples at C and D with the negatives. Right here, this is really negative times 2 squared. So I'm going to go ahead and turn that 2 squared into a 4. And then a to the 5th cubed. I'm going to do that just so it's simpler to think about. Because remember, that's negative 2 times 2. It's the 2 that's being squared, not the negative 2 because there's not parentheses around it. So now, if I separate these out, I have negative 4 cubed, and I have a to the 5th cubed. So negative 4 cubed does really mean negative 4 times negative 4 times negative 4. And that ends up being negative 64. And a to the 5th to the 3rd, if I multiply my exponents using that shortcut, a to the 15th. And that's my final answer. The next part, raising a quotient to a power. Almost done. It's long sections. Really what that's saying is that you're going to have some fractions. So if I have 2/3, the quotient means division, answer to a division problem. So if I have 2/3 and I have parentheses that go around the 2 and the 3, so from the top of the numerator to the bottom, and I raise it to the 3rd power, You can think of that as two different ways. You can think of it as 2/3 times 2/3 times 2/3. You can also think of it as 2 to the third over 3 to the third. It doesn't matter which way you go. It's kind of easier to think about it this way, especially when we start getting into variables. And so because these parentheses go all the way down, you can separate them out and think of them as 2 cubed and 3 cubed. Then we're going to simplify that. 2 cubed can actually be simplified farther, so 2 times 2 is 4, 4 times 2 is 8. And then 3 cubed is 27, so the answer is 8/27. The next example is A over, no, that's an A, kind of looks like a 9. There we go. Oh yeah, that's pretty sad. A over B to the 9th. That is the same as A to the 9th over B to the 9th. And really I can't solve any farther because I don't know what A and B is, so I'm done. The next one is A plus B over 5 squared. So I'm going to separate those because, again, the parentheses go from the top to the bottom, from the numerator to the denominator, so that means they're all being squared. So I have A plus B, and that's squared, over 5 squared. Well, 5 squared can still be simplified, so I can call that 25. But I can't really do anything with the A plus B because, again, you can't add unlike terms. And because it says A plus B, then you're stuck. You have to leave that. So that would be my final answer. There is a summary of the rules on page 741 in your textbook. I would suggest maybe putting that on a note card or something so that you have that accessible when you're studying. You can't use it on the tests or quizzes, but just so that when you're doing when you're working on your homework, if you've forgotten something, you can quickly look at that. The biggest difference in this whole section, the big aha in this whole section, is for you to understand the difference between, like, saying A cubed times A squared, and the shortcut being adding those, so A to the 5th. And remember, the reason why is because you have 3 A's times 2 more A's. And then knowing that A cubed squared would be A to the 6th. So the shortcut is multiplying. And again, the reason for that would be that you would have 2 sets of 3 A's. So knowing the difference between these two, that is the big concept for this section. So one more part in this section is called combining the rules. So putting it all together, there's 3 examples. First one looks like this: 2A squared times 3, ooh, yucky, times 3A cubed. So if I wanted to simplify that, remember that the parentheses are around the 2 and the A. So if I take 2 squared and A squared, that's really 4A squared. Okay? And then to simplify the right-hand part of it, if I have 3A cubed, that's really 3 cubed and A cubed. So 3 cubed is 3 times 3 is 9, 9 times 3 is 27, A cubed. I can go farther because there's whole numbers, so they're alike, and there's exponents with the same base. So I can combine there. So 27 times 4 is 108, and A squared times A cubed is A to the 5th. So that would be my final answer. Next example is a squared b cubed over c, all taken to the fourth power. So again, those parentheses are around the numerator and denominator, so I'm going to separate those out. I'm going to say a squared b cubed to the fourth over c to the fourth. Well, I know that I can take these and take them each to the fourth power. So a squared to the fourth, b cubed to the fourth over c to the fourth. So I know using my power to power rule, I know I can multiply those, my little trick. So that would be a to the 8th and b to the 12th over c to the 4th. And that's as far as I could go. And the last example is 2x cubed y all squared times negative 4x squared y cubed cubed. So I'm going to go ahead and separate all these out. I know that each one of these is being squared. So I'm going to write it all out. X cubed squared y squared negative 4 cubed x squared cubed and y cubed cubed. You wouldn't have to write it all out like this. You could take your shortcuts. I just don't want to skip steps in the notes in case you're confused. So 2 squared is 4. X cubed squared is x to the 6 using my power to power rule. Y squared is y squared. Negative 4 cubed is negative 4 times negative 4 times negative 4. Negative 4 times negative 4 is 16 times another negative 4 is negative 64. X squared cubed is x to the 6th, and y cubed cubed is x to the 9th, using those power to power rules. Now, since all the powers are gone, I can combine my exponents with a base of x. And I know that x to the 6th times another x to the 6th, the product rule is going to be x to the 12th. And y squared times y to the 9th is going to be y to the 11th. Again, I use that product rule of adding my exponents. And I know that 4 times negative 64 is negative 256. We usually just put the whole numbers out front. Okay, and that's the end of the notes. Good luck on your assignment. I hope this was useful for you.